The carbon cycle is a biogeochemical cycle that comprises of events that acts as the key for life on Earth. Human activity has caused carbon to be constantly added into the atmosphere. In 2017, global energy-related carbon emissions is shown to be 32.5 gigatons, and the global energy demand has risen by 2.1%, which is more than twice compared to the previous year. As a result, the carbon dioxide emission increased by 1.4% despite remaining stagnant for 3 years. In Malaysia, the carbon dioxide emission is at a current level of 255.8 million tons, and the cement industry is shown to be the largest source of these emissions, with 900 kilograms of carbon dioxide released for every production ton of cement. In the year 2000, the cement industry was recorded to have released 1.4 gigatons of carbon dioxide, which is roughly 5% of the worldwide carbon dioxide emission due to human activity. This high carbon dioxide emission causes harmful environmental impact to our Earth. The dangers of these emissions include the greenhouse effect and global warming. Have you ever wondered why the range in temperature on the Moon differs greatly than the range on Earth? It's due to the presence of greenhouse gases on the Earth that absorb some of the Sun's energy. This process allows the Earth to remain at roughly 33 degrees Celsius, also allowing life on Earth. Due to various human activities, the concentration of greenhouse gases increase, thus trapping extra heat from the Sun and causing the temperature of the Earth to rise. This leads to the next environmental impact known as global warming. The extra heat trapped causes an increase in global temperature of our planet and eventually the loss of mass for the polar ice sheets. The rate of change of ice mass in Antarctica shows a declining rate of change of 127 gigatons per year, and Greenland with 286 gigatons per year. This is the primary cause of the rise in sea levels, which has risen up to 86.5 millimeters since 1993. Due to these harmful emissions in our air, many countries have started to take necessary measures to reduce the carbon dioxide emission. Therefore, synthesis of methanol from captured carbon dioxide is the solution. The process begins with carbon dioxide being extracted directly from various sources such as the cement industry and power plant. Then a carbon capture plant will refine to separate the carbon dioxide from other components. In parallel, electrolysis of water will take place where water molecules are being decomposed to give hydrogen and oxygen. The high energy cost for electrolysis allows us to find other options by using excess energy from other industries and production, or producing hydrogen through biomass and other renewable sources such as from the production of syngas. The process is continued where carbon dioxide and hydrogen are mixed together with a ratio of 1:9 and fed into a reactor to react over a homogeneous Ru-based catalyst in ethyl solvent, where the reaction will take place at a temperature of 145 degrees Celsius and a pressure of 75 atm. This would generate methanol in a direct conversion with high selectivity, so 79% of methanol is being produced from carbon dioxide. So how does this process benefit the economy? Methanol is a key component of many chemicals that are integral parts of our daily lives. The global methanol installed production capacity has been growing at an average annual rate of roughly 10%. With this process, 1.5 tons of carbon dioxide can approximately produce 1 ton of methanol, which can then be converted and used as multiple valuable products, such as feedstock for plastic industry, alternative fuel, and power generation. One of the fastest growing and largest markets for methanol is the production of light olefins, the backbone of the plastic industry. Methanol has good octane properties compared to gasoline, which allows engine optimization. It can also be blended with gasoline with a ratio of 85% gasoline and 15% methanol to be used in existing road vehicles, further reducing the carbon dioxide emission. This product is emerging as a fuel for electricity generation due to its clean burning characteristics. It requires approximately 1,200 tons of methanol to produce 1 megawatt of electricity. All these uses would provide a big income as the three products possesses a high value of worth. In conclusion, the release of carbon dioxide into the atmosphere is one vital example of planetary calamity. Therefore, we must realize that in the end, progression would not make any good if it poisons the very air we need to survive.